Welcome, this is the 5.1 Ready, Set, Go homework solutions. Alright, we have here the ready part. It says, to substitute the given point into the equation to determine which order pairs satisfy the systems of linear equations. Graph both equations and label the points of intersections to verify the solution. So we have 1 and 2 here. I'm going to work in Paint, okay? Alright, so let's graph this and this, okay? So I'm just going to show you that this is going to be in blue, okay? Alright, so here it says for this one, for the blue one, the slope is equal to 3 over 1, and the y-intercept, which is b, is equal to -2, okay? That means you're going to put a dot here at -2. So this is 0, 0. So this is 0, 0. Right? And this is -1, -2. So put a dot here at -2. Then the slope here, it says, right? So this is going to be 3 up and 1 to the right. Okay? So 3 up. So 1, 2, 3. And 1 to the right. Okay, you can do that again if you want. 1, 2, 3, cross 1. Okay, gives us a very good line. Okay, good. Alright, and let's do the next one. Y equals to x. So, for that one, I'm going to probably make it red. Right? For this one, the slope for that one is going to be 1 over 1, where the y-intercept is equal to 0. Right? So let's do that. It starts here at 0, 0, goes up 1, across 1, right? Up 1, across 1, up 1, across 1. Right? So that should be where the line is. So, it's very hard to tell, but 1, 1 would be a solution. Okay, and what do you think? Okay, hold on, let's just see. Right, I'm just gonna pull up Desmos, okay? Okay. Right. So let's just put that in here. So y equals to 3x minus 2. And the other one was y equals to x. Right? So it looks like it only intersected at one point. 2, 2 here was the only intersection, okay? So 2, 2 was the only intersection. Right? But I just want to graph it for you so you could see it. Nothing else would be a solution. So the only solution for this one would be, the only thing is solution would be this one at 2, 2. Alright? Let's do the next one. Again, I'm just going to graph it because some of you asked because you need extra help on graphing. So I'm just going to do all those steps for you, okay? Alright, let's do that one. So that one, the slope is going to be 2 over 1, right? Because that is in front of the x. And the y-intercept here was be 3. It's over 1 because the number 2 can be divided by 1. And slope is always in terms of a fraction, okay? Alright, so here's 0, 0, 1, 2, 3. That's 0. That's 3 for the y-intercept. And it says up 2, across 1, up 2, across 1. Alright. So there you go. That is how that should look like. Okay, good. And let's do this one. This is going to be y equals to x plus 5. Let's just get that information. So for this one, the slope would be, what is the number in front of the x? It's really a 1 over 1. Okay, because there's a 1 out in front. And the y-intercept, which is 5. Alright, so let's do that. So we go to 5. So that was 0, 1, 2, 3, 4, 5 is right here. And we go up 1, across 1, Up 1 across 1. Oop, that looks like that's a solution. Right? And I think that one is 0, 1, 2. That looks like 2, 7. Right? Oh, sorry. Just do a line for that one. Here you go. Here you go. And that one looks like 2, 7. The intersection at that point is 2, 7. Alright, let's just pull up Desmos to see it. Again, you won't have Desmos on the tests, but I wanted to show you how you can use Desmos to check your work. So y equals 2x, and the other one was y is equal to x plus 5. The intersection to be 2, 7. Should be 2, 7. Yep, perfect. We graphed it right. It is at 2, 7 would be that solution. So we would say this. Okay. 2, 7 would be the solution for this one. Right? Okay. So let me just grab that. Okay. Dropped it over here. Okay. And let's do this one. Again, this one you can just graph, or we could pull it up on Desmos. Okay, so for that one, I'm going to show you how to graph it. Right? Because again, some of you request me to show the. Right? Okay, so again, let's do that. We are going to graph this equation, y equals x plus 3. So the things that we need is the slope, which is the number in front of the x. The number in front of the x is 1 over 1. The y-intercept, which is the b value, here is that number that is not attached. It's attached via the addition sign. M equals to slope, is equal to 1 over 1, and the y-intercept is equal to 3. Right? So let's go. It's from, this is 0, 1, 2, 3, looks like right there. And we go up 1 across 1. So there we go. We can make that line. Up 1 across 1. Okay. Let's do the next one. This one looks like we have to find the slope, then the y-intercept. That's the only way we can graph. So that one, what is the number in front of the x? That's going to give us the slope. The number in front of the x is the slope. So the slope here is negative 2 over 1. And the y-intercept, which is b, is equal to 3. So put a dot here. This is 0, 1, 2, 3. Ooh, it has the same y-intercept. That's interesting. Okay, go down 1, 2, across 1. Right? Because the negative means you go down. This is a negative slope. Okay? So you're going down. Right? Just for some reference, if you want to read slope, okay, right, the top number, right, the top number is going to be divided by the bottom number. Okay, the top tells you if you're going to go up or down, depending if it's negative or positive. Okay, you go up or down, and the bottom says you're going to the right. Right? In this case, it was negative. That's why we went down. Right? Looks like it intersects here as the y-intercept. Alright, let's just check that by pulling it up in Desmos and doing it. So it's y equals x plus 3, and the bottom would be y equals negative 2x plus 3. Where's the intersection? Yep, it does intersect at the y-intercept of 0, 3. Let's do this one now. Okay, again, the first one, I'm going to make that blue. Right, the slope is the value in front of the x. So the slope here, it is 3 over 1. Because any number can be turned into a fraction by just dividing it by 1. And the y-intercept, which is b, is equal to negative 8. Alright, so here's 0, 0. -1, -2, -3, -4, -5, -6, -7, -8. Right there. Goes up 3, right? Because that's a positive 3, so that's up 3. 1, 2, 3 across 1. 1, 2, 3 across 1, right? I just apply the slope multiple times so I could just get a really good line. Looks good. What about this one? Right, that one looks like it has a slope. The number in front is a negative, so that is -1 over 1. And the y-intercept there looks like it's 0 because there's no number attached to the right. So we start here at 0, 0. Then we go down 1, across 1, down 1, across 1. Ooh, that looks like that's 3, -2. So I said the solution for that one would be 3, -2, right? Looks like 3, -2. That's my guess. Let's see if Desmos confirms, okay? Y equals 3x minus 8. And the other one is just y equals minus x. Am I right? Yep. 2, -2. Right? Good. Alright, so we would say here, we forgot to type it, the intersection. So the solution is at, we said 2, -2. And for this one, I believe it was the y-intercept, which was the solution was at the y-intercept is at 0, 3, right? 1, 2, 3. Good. So there you go. Those are all the solutions for the go part, I believe. Right, there you go. That's if you need to see it again. 1, 2. Okay. 3, 4. Alright, let's do the set part. Alright, so in here it says a theater wants to take in at least 2,000 for the matinee. Children tickets cost $5 each and adult tickets cost $10 each. The theater can seat up to 350 people. Find 5 combination of children and adult tickets that will make the 2,000 goal. Alright, so this one, very straightforward. So there are 2 equations, one cost equation and one amount equation. Okay, what do I mean by the cost? This is going to be the dollar, right? This is going to be the physical amount of something. So this is the, you know, how much you're going to count, right? So this is like 1, 2, 3, right? These are your integers, okay? Right, but this is a dollar value. All right, so because you could count, so here this is your amount equation. You're literally counting people. So the theater can seat up to 300 people. Is it equal to 300 people? No, the equal sign means there has to be 350. But when this says can seat up to, right, it means that it has to be less than or equal to, right? It can never be over 350, right? Can seat up to, can never be over, right? That's why you use the less than or equal to. Here's the cost. Oops, sorry. Less than or equal to, right? Sorry, less than or equal to. Okay, sorry, good. Here, this says that the theater wants to take in at least $200 for the matinee, $5 each for the children, and the adult tickets cost $10 each. Here's the cost equation, right? Because it's $5 times X, which is the amount of tickets for the children, $10 times the Y, has to be less than 2,000, right? No, remember they want to at least take that in. So we want that to be more than. right? Because that's the bottom value. So they want to at least make 2,000. They could make more. They could make 2,005, 2,500, 3,000, right? They want to make more than that. Okay. So here are your two equations, right? Now, okay, we want to see different combinations for this. Okay. To do this, it's best if we graph it and we see different solutions, right? So let's put this in Y-intercept form. So Y-intercept form should look like this, because you're just subtracting the x over to both sides. So that should be that. And the other one, I think, should look like, hold on, 10y less than negative 5x plus 2,000, right? But you want to divide the 10 to both sides. So this is divided by 10, right? Which can be simplified. This is also going to be divided by 10. Okay. Right, and I think that can be simplified. Let's see. Yep, this becomes negative 1/2, and this becomes 200. Right? Good. Now we graph this. We grab this, right? We can just use this equation in decimals, right? Okay. And y is less than or equal to negative x plus 250. The other one looks like this, right? Okay. I think it's right. Good. You know what? Let's just keep the slope the way it was. Okay, I think it works much better if we just keep it the way it is. Okay, alright, so that should be negative 1 divided by 2. Alright, good, good. Do we divide? Good, alright. So, here we go. Oop, let me just shrink this. Sorry. Oh, the scale here is off. So, let's just, the x-axis, let's just do it. And we want it to go up to, let's make it go up to 1,000. This is how you can just adjust it. Alright, perfect. So each one of these goes up. Perfect. So here, I'm just gonna take this out real quick. Okay, so if we just had one equation, if we just have the x is less than or equal to negative x plus 300, it would look like this. Okay, then we add the other one, right? This is the amount of tickets. Now this is the price of the tickets, right? That's the solution. You're using 0, 0 to test. So this is the intersection, right? So those are your different solutions. So these are all your possibilities. So you can use the point 100, 200. So you could have 100. You could have 100 children and 200 adults, right? That will still get you your ticket. You could have 300 just adults, right? You can't really have negative values, okay? So what you can do here is, let me grab the image for you, okay? Right? And we could talk about the graph really quick. Give me a second here. Right? Alright, so okay. So here, right? So the bottom axis here represents the x-axis, shows the x is the, so this is the children ticket, and the y-axis, oops, right, the y-axis is the adult tickets. Okay, so here are the different permutations. Right, you could have 100 children tickets and 200 adult tickets. You could have 100 children ticket and 225 right? Anything in this intersection would be a valid answer. Okay? Alright, let's do the next one. The Utah Jazz scored 102 points in a recent game. The team scored 3 points, 2 points, and many free throws worth 1 point. Find 5 combinations of basketballs that would add up to 102 points. So, there's only one equation here, the point equation, right? And to do the point equation, we let some variables. So I let x be the 3-point shot, the y be the 2-point shot, make that blue, and the z be the 1-point shot. Okay, and all of them need to be together in this point equation. So 3 times, right, because 3 is the point value, times the amount of those 3-point shots, so 3x plus 2y plus 1z has to be equal to 102. That's the point equation, right? You could come up with different permutations, okay, for this. You could just test it, right? Okay. You can't really graph this because it will require us to do this in 3 dimensions because of the extra variable. Okay, so alright, so there's not a lot. You would just have to try different combinations for this. Okay, alright. I could do one if you would like to see it. Alright, so let's do. Okay, very easy. I like to make, so I can make z equal to, let's say, 100 z's, right? 100 free throws. Okay, that would be 100 points. Then I just add a y equals to 2. Okay, or I could do, let's say, y is equal to, let's say, 50. That would give me 100 points. Then 1z, right? And no free throws, right? So I could say x is equal to 0 if you want. Those are just different combinations, okay? Alright, so just try it out, but that would be the equation for it, okay? Alright, let's keep going now. You're going to be using these shapes in here and to just fill it in. Right, use as many of these shapes you combine to fill much of the 12 by 12 grid. You can rotate, just like Tetris. There's not a lot of explanation for this one. Okay, all right. Let's go to the go part. Okay, the go part. The question asks us to graph these and find. Right, so just graph these and look for these solutions. Okay. All right. Okay. So for these, right, if you want to see the graph, you could just graph it in decimals. Okay, so here, right, they asked us here, let me give you the instructions. Okay, so you're going to determine if 3, 5 is the solution to the equation, so, or find 2 other points rather than 3, 5 that is also a solution to this equation. Okay, easy point, put into decimals, you could check it. Okay, alright, but let me show you it mechanically. Okay, alright, so let's just get the graph first. Okay, alright, let's see, give me a second here because I'm gonna try to pull it up in Paint for you. Alright, okay, again, because some of you just would like more practice on graphing, that's why I'm going over it in detail for you. Okay, right here we say the slope is equal to 2 over 1. Right, that's always going to be green. And the y-intercept, which is purple, b is equal to this number here, -1. Okay, so you put the dot here. Right. At -1, so 0, -1. You go up to 1, 2, across 1. Then you want to connect the dots. Okay, you can do it again, up to, across 1. Okay, then you can connect the dots. Right. There you go. Those would be, so your solutions, we would look at it, right? We would see what is this dot, right? What would be this dot here? This dot, let's just make it red so you could see, right? This dot looks like that is 0 in the x, negative 1 in the y. That's the y-intercept. Okay. The next dot would be 1, 2. So that would be 1, 2, right? Because we went up 2 units in the y, 1 over in the x. And the last one would be, right, 1, 2. So that's 2. 1, 2, 3. So that's 2. That should be 4. Hold on. 1, 2, 3. 1, 2 over 1. 1, 2 over 1. 1, 2. 1, 2, 3. Should be 4. Because it's going up by 2 each time. The next one should be 4. Am I counting it wrong? 2 over 1. 1, 2 over 1. Right? That should be 2 over 4. Let's just double check by putting it into decimals. Something feels off. Hold on. Let's just put it into decimals. See what happens. Okay. Y equals 2x minus 1. Let's change back the scale. Right, let's just put it at 0, 0. Let's make that, what, 15, 15. Alright, so zoom in. Alright. Oh, 15, 15, 0, 0. Alright, so let's see if I was right. So the first one was a 0, 1. The next one was 1, 1. The slope was 2, 1. Right? And the next one should have been 2, 3. 2, 3. The next one would be 3, 5. Haha, that's why I was off. Okay, so this is more correct, right? So the first one would be this. Then the next one would have been, right, because the x is going up by 1 and the y is going up by 2. So the next one would be 1, 1. Okay, and the next one after that would be 2, 3. Then the next one after that, which we didn't make a dot for, would be 3, 5. Right? So you would say, yes, it is a solution. So it would say, yes, 3, 5 is a solution. Okay, let's do this one. So the slope here is equal to 1 over 3. And the y-intercept is 2. Okay. Right. So, where's 2? 1, 2. It looks like we're going up 1, across 3. 1, up 1, 1, 2, 3, across 3. Up 1, across 3. 1, 2, 3. Right. Good. Connect the lines. Alright. Okay, so let's see the points. So the y-intercept here is at 0, 2. And we just keep going on the slope. The next order pair looks like we add, what, 1 to the y and 3 to the x. 1 to the y, 3 to the x. So, right? So 1, so this is 0, 1, 2, 3, so that's correct. And 1 to the x, so that's 3 over 3. Okay, oops, nope. So nope, we already see here that you see how it's not even, it's 3 3. So we say no, 3 5 is not a solution. Okay, there you go. That's the first part of the go part. So let me just grab that for you here. Go here, paste that. Right. Okay. Here again. All right. This time we're just gonna save some time and just put it in Desmos. Okay. Or do you want me to do it again? All right. You could watch the other videos. Or me doing the other problems if you need more detail on how to graph it, but just for the time limit of the video, we're just going to do it in Desmos because it's quicker. Okay. Alright, here's the first one. Alright, y equals 2, 3x plus 5. Right? So the first one looks like it is 0, 5. Right? Then 1 looks like that's 1, 2. Right? Then 2, -1. Let's see where. Oh no, there's no way because it goes down. So for 3, it's probably like right here. Yeah, so it's 3, -4. So this one, 3, 5 is not a solution. Okay, for this one, 3, 5 is not a solution. Let's look at this one. Let's put that in Desmos as well. Okay. So that one was by 5x plus 4. Alright, let's see if that one works. Alright, so 0, 4. Let's see what else. I think it's, oh, that's a fraction. 3, 5. No, 3, 5 is not solution. Alright, it's around 3, 2. Right? So we'd say these two, 3, 5 is not a solution. So 3, 5 is not a solution to this one or this one, nor this one, only this one. Okay? Alright. The next one, okay? The table below represents different arithmetic sequence, right? Keyword arithmetic sequence, so it's linear. Find the missing number, then write the explicit. Alright, so just to let you know, this, you need to find the slope, or we also call that the common difference. Okay, remember? Right? I'm just gonna give you the equation again. So it was y2 minus y1 divided by x2 minus x1. Right? So that's how we find the slope. Okay? So let's do that. Okay? So what's y2? y2 is -7 minus, that is a 17. y2, x2 is 4. And minus x1, which is a 1. Okay, we can simplify that. Alright, so we have here -17, right? -7 minus 17. Alright, so again, it is a negative number, subtract a negative, so it's going to be a larger negative, if that makes sense. Okay? Alright, so again, if you want to use a calculator to make your life easier, okay, so this would be -24. And 4 minus 3 is 3. Okay? Right? Again, that could be simplified. Once again. So -24 divided by 3. So this becomes -8 over 1. What does that mean? Right? This means the y is what? Subtract 8. Right? So the common difference is subtract 8. Okay, so 17 subtract 8, right? Subtract 8 would be the next one. So this one would be 9, right? 9 subtract 8 would be 1, and 1 subtract 8 would be equal to your 7, negative 7. Okay, good. Right, that's just doing all the work. Here we have the slope is right here. We just need the y-intercept. So we want to find the y-intercept. So I think there is a row to the left, right? Before, so 1, 2, 3, 4. So I go backwards. That's 0, right? So to go forward, I had to subtract 8. Okay. So to go backwards, it would be 17 plus 8. So 17 plus 8, that is 25. Right? Good. Because you go forward, you apply the common difference. To go backwards, you apply the opposite of the common difference. So here, right, the slope is right there. You have the y-intercept, that's equal to 25. So your equation would be y equals to the slope, negative 8x, okay, plus 25, which is the y-intercept. Right, okay. Ooh, same thing here. But the, right, let's find the slope and the common difference here. But the thing here, it was negative 7 minus 17, but the x values are different. This is 13 minus 1. So this is 13 minus 1. Okay, this would become a 12. This is still negative 24. You simplify this, I think it should be a smaller slope. Okay, let's just do that. Yep, that is negative 2 over 1. Okay, so the common difference is negative 2. Right, so let's do that. So 17 minus 2, okay, that is 15. Then the next one would be 13. The next one would be 11, right? We keep minusing 2. 9. Oops, sorry. Then it is 7. 5. 3. 1. Then negative 1. You keep minusing 2. Right? Negative 3. Negative 5. Then negative 7. Right? Here we have to find the y-intercept, so we have to look at the 0 value. So to go forward, it's a negative 2. To go backwards, you add 2. So this becomes 19. So your equation for this one would be y equals to negative 2x plus 19. Right? Nope. Alright, 14's down here. Let's just do that. Okay. Alright. So this time it is same thing, right? But this time it is 7 and 1 for the y, so it's 7 and 1. Whoa, that does not become a pretty number, because that is your 17 minus, sorry, negative 7 minus 17 is your negative 24, but your 7 minus 1 is your 6. Okay? This can be simplified into negative 4 over 1. So your common, oops, sorry about that. So here you would say your common difference is negative 4. So let's go to the next one, 17 minus 4, right, which is 13. And the next one would be 9. Then it would be 5. 1. It would be negative 3, then negative 7. Okay. Again, let's find the y-intercept. A row to the left, so this is 0. And go forward, it's -4. To go backward, it's add 4. 17 plus 4 is 21. So the y-intercept here is 21. Let's plug into your equation. Y equals to -4x plus 21. Right? So they say each of these sequences above begins and ends with the same number. Would the graph of each sequence represent the same line? Let's look at the equation. Right? This is this is number 14. That is number 13. And this was number 12, right? Right. Very simple. Let's just graph it in decimals and see, right? Those are our three equations. Let's just graph it in decimals and see what happens. That's the first one. That's the second one. That's the third one. No, look. They're all different. Well, they all intersect here, but they all look different. They all have slopes. They all have different y-intercepts. Look. So, no. So, they are not the same. Or they do not represent the same line. If you graph each of the sequence and make them continuous by connecting the points, where would they intersect? Yeah, just look at decimals. I think they intersect here at 117. Right here, 117. So the intersection here, the intersection is 1,17. Alright, so there you go. I know it's a long video because I did a lot of the graphing for you, right? Because again, in class, you all asked me to demonstrate the graphing, so I wanted to go over it in detail for you here. Okay? But there you go. Those are all the homework solutions for 5.1.